Welcome, everyone. Um, those online and those in person. I want to welcome everybody to the April meeting of the Horicon Marsh Bird Club. Um, got a very good crowd tonight, both in person and a combination of those online. So it's working out pretty good. Um, we'll start out with a quick, just a synopsis of what everybody's been kind of seeing around. Migration has um, taken hold a little bit here. So we got some tree swallows, phoebes, kinglets, um, hermit thrushes. Purple martins are back in just very few limited numbers here at our um, nesting complex here. Waterfowl, some of the wood ducks are starting to sit on eggs. I've got some Whittermergansers sitting on eggs. I've got 3 boxes occupied at home. All are starting to incubate. We've got a couple here at the Ed Center as well. Wood ducks are starting to incubate, and um, some other nest boxes are being occupied and eggs laid. So, Liz, do you have some things that upcoming that you are wildlife educator here at the center? Just mention, of course, bird festivals coming up in less than a couple 3 weeks. Oh boy, uh, 3 weeks. Things are progressing pretty well. A lot of the trips are filled. There is still a few openings on some of the trips. If you want to get on some of the bus tours, yeah, I suggest you do it very quickly. Um, so, and we're also looking for some volunteers to help out Saturday and especially Sunday to help out with just some questions and some selling of some T-shirts and things at our club table at during that time here at the Education Center. Um, yeah, so we're looking forward to that. Liz is here, so she's gonna okay.
Me on Zoom too. All right. Thanks so much for giving me a chance to chat a little bit about what's going on. As Jeff mentioned, the Bird Festival is coming up. So right now, where we could use the most help for the table for the festival is Sunday morning from like 8 till noon. So if anybody is available Sunday morning, 8 to noon, it entails answering general questions about where birds are being seen. And we'll have DNR staff there too, so you don't have to know everything. That's totally fine, and selling some of the t-shirts, which we try to make as simple as possible. So if you are available to help that Sunday morning from 8 to noon, just let me know or let Jeff know and we can get you signed up. We're also going to be hosting a bird lab that day, which is really an event that's open, no registration required, but geared towards kids and families to get them excited and interested in birds. And so we'll have everything from make your own bird nest to trying out different beaks with different tools, to actually running into a volleyball net like a mist net and then getting banded. So if that sounds intriguing to you, again, see me or talk to Jeff or Suze and let us know you're interested and we can give you some more details on that. But it's a fun way to get kids and families involved with birding in a little bit different and interactive way to hopefully garner that interest at some point. And then following the Bird Festival, that next weekend on Saturday, May 17th, we have our Wildflowers for Wildlife event, which is our big native plant sale. So if you are looking to put natives in your yard this year, that will be from 9 until 1 on Saturday, May 17th. So add that to your calendar as well. And we have a number of other events that are getting posted. Horiconmarsh.org is our friends group website that has everything on there. If you are interested in art, in early May, we will be doing some paint classes of the rose-breasted grosbeak, which is our bird festival theme bird as well for this year. So trying to theme that a little bit if you are interested in doing so. But if anybody's interested in volunteering for those couple events, find any of us and we'd be happy to get you more details. So thank you. I appreciate that.
Thanks, Liz. always good to hear about things happening around our education center. Um, Lots of volunteers here and online do a great job to help spread the word. So I'm going to just mention a little bit about the upcoming May meeting. Um, the meeting for May will be a members only meeting. So, and I'm saying that because we are getting the Blue Heron Landing um, Horicon Marsh Boat Tours is donating a a trip for the Bird Club. And if you're not a member, it's easy to sign up and become a member. This is kind of our incentive to become a member to get one of the benefits. So Troy and Joe Del Kirkhoff are the new owners of the Blue Heron Landing, are donating this trip. We're going to have a pass the hat um, for donations. Please be generous. We will post their normal um, prices on that, and hopefully we can come to that and make it worth their while as well. Troy and Jordell have really put a lot of effort into resurrecting the Blue Heron Landing and the boat tours. And for those that are not familiar, they also do sandwiches and soups and coffee, and they have a limited beer selection there as well. So um, you'll see a bunch of details in the May newsletter on how to sign up for that. They are offering as well a box lunch to go with that. So there's going to be several different options to go with that. So look for in the newsletter, or if you are just um, joining, we'll try to get that information to you. Okay, Suzanne said she will send it out about the 1st of May. So we have to have all the food options done the week prior to that. So that would be what, the 10th, 12th, or something like that. All of that in. Um, so with that, anybody have any sightings they want to report? Leslie?
Squirrel on Saturday during the crane count on the lake. And then we had the 7 pelicans on Mississippi as we were coming up today.
Okay. So those online, Leslie has had some a couple purple finches today, some pelicans during the um, crane count. Leslie, do you have a quick synopsis of the crane count?
Day.
Oh, yes. Okay, that was the other thing too. We got some blackneck stilts in the area already. So okay. For those online, Leslie has reported they had about 180 cranes during the crane count, which is down quite a bit. Um, we're in a drought this spring, so it's kind of be expected. So stay tuned. Loon, yes. So the loon, yes, probably loon. We've had a couple of them on Beaver Dam Lake. Um, I don't know if they're still there. It could very well be. Usually between April 1st and April 10th is about the time we go looking for loons. There's probably still a bunch in the area, but they're working their way through now. So uh, get out there now if you want to see them locally before they're all headed up north. Any other quick, Albert? Oh, okay. Albert has a pileated woodpecker nesting. Uh, okay. So So for us in Dodge County, that's a pretty good bird. Uh, uh, our forests are a little too small and too fragmented to normally get those, but anytime we see a pileated, there's always a pretty good sighting. So with that, we're going to introduce our speaker tonight. Um, who would have thought, even 5, even 10 years ago, that we would today be able to have our phones tell us what bird is singing, or just how many birds are going to be in the area by just clicking on a computer program, and bird migration via radar. It's total, science fiction, but yet here we are today, and it's happening. And it's happening, in almost real time. I woke up this morning, I don't know, 3 o'clock. Well, I got to check BirdCast, see what's going on. Sure enough, there was lots of movement in our area. So I want to thank our speaker today, coming from New York City, Andrew Farnsworth of the Cornell Lab of Ornithology, and he's going to talk about the BirdCast. BirdCast is a collaborative project that employs the expertise of computer scientists and ornithologists to harness the power of big data to study movements of birds and, more broadly, capture the spectacle of bird migration. He's going to be speaking about monitoring bird migration with data by citizen scientists and the U.S. Weather Surveillance Radar Network, among other sources of information to forecast when, where, and how many birds will migrate, and to observe these movements in near real time on a continental scale. Andrew will discuss magnitudes and extensive migration, and challenges of monitoring bird nocturnal movements at scales relevant to their biology, and ways we use radar to remotely sense interconnected patterns in time and space. Birds truly represent dynamic and global communities, and recent trends and methods and analysis showcase what may be in the future of bird migration research and conservation to study birds. Complex roles in terrestrial, aerial, and aquatic systems, the age of big data and observation, the potential of what remains for us is to learn is inspiring. And that's where all your eBird data goes, folks. That helps that right there. So with that, Andrew, can you take it away?
For sure. Thank you, Jeff. I appreciate it. Thank you all out there online and in the audience in person. Sorry, I'm not there for you actually in the flesh, but it's nice to speak to you. So as Jeff mentioned, I'm going to be talking about BirdCast tonight. I've had the good fortune to be part of this project for most of the last 25 years in its various incarnations, and that's certainly enough time to have done a lot of really fun science, a lot of great birding, and now have some perspectives on how things have changed, and obviously all of these different subjects that we're going to be sort of covering over the next 30 to 40 minutes, something like that. So let me get into it. Now, hopefully, many of you have seen this website, birdcast.info. Very recently, we reclaimed birdcast.org, which I'm very happy to say. So both of those go to the same place. This wonderful project that has been at the core a collaboration between the ornithologists and birders on the one hand, kind of the people with the expertise of the biology, if you will, and the computer scientists on the other hand, the expertise in the data analytics, the visualizations, the processes of how to handle massive amounts of data, with, of course, this goal of showcasing the spectacle of migration. And when we started, I think the hope was that we would one day be able to do these kinds of analyses and visualizations and forecasts and all these things like on some kind of handheld device. And it was sort of like, probably never going to happen. Well, it happened, and it's been a wonderful journey. And let's get into talking about it. I should say at the outset, this is not just my project. I've had the good fortune to work on it for many years, but it's been the collaborations with different universities, including University of Illinois, Colorado State University, University of Massachusetts, also a diversity of funding sources, including what we would never be able to do this without the work of Amazon web servers that provide all these data from radar for free, but also support from National Science Foundation. So it's a team for sure, and it's quite an amazing team. So I've been watching birds for most of the last 47 or 48 years. That's like a huge percentage of my life. And so the reason I am interested in BirdCast and pursue it is I've been fascinated by bird migration my whole life, and been a birder for my whole life. But I also do this because I'm deeply concerned. Some of that knowledge about birds and the experiences I've had over that time highlight for me how many changes have happened. And I'm sure many of you have had this experience too of either friends or perhaps your own personal observations of feeling like, well, there just aren't in many cases as many birds as we used to see, or diversity has changed in ways that are much lower than we remember. And there are some serious issues with bird populations in North America. We've seen big declines. This was from a paper that came out about 6 years ago, highlighting this incredible loss of 3 billion birds, breeding birds, over the course of the last 50 years, this enormous impact to populations. And so, along with that passion for birds and for wanting to go out into the field and see birds and experience them, comes this idea that we just need to be better stewards. We've had some problems over the 20th and 21st centuries for sure, and before. And let's see if we can gather enough information to understand what those are about and why that's happened. And then moving forward, see if we can correct those and reverse this horrible curve that you see on the left-hand side of the screen. And in particular, a curve that's driven a lot by migrant populations, birds that are on the move all through the Western Hemisphere. So one way to frame this situation with biodiversity loss or bird populations, changes in populations, yeah, we can think about it from the perspective of where are humans on the planet, and what have the impacts of humans been in different places. This is just kind of a graphic that maybe some of you have seen. You certainly understand the concept that wherever we as a species go, we impact our environment, we alter it, we change it, and there are not many places on the planet yet that we have not touched. And yeah, this has some very dramatic impacts when it comes to the loss of forests, the change of habitats, the conversion of land, and so to what happens with ecosystems and species diversity and so on. And I also think it's important to remember that where people are, there's also an opportunity. So yes, we can do destructive and impactful things. And some of those impacts can be positive. And for example, thinking about this kind of global footprint from the perspective of eBird, right? And eBirders and citizen scientists and community scientists and birders like yourselves that are going out and gathering data. So each one of the dots that you see on this map represents an observation from someone. Some of them are yours for sure. Some of them are mine. Some of them are my colleagues at the lab. Some of them are my colleagues in Switzerland or Australia or wherever, and friends around the planet. And this more than 2 billion observation data set is the upside of having this incredible global footprint. There are no political boundaries drawn on these maps. This is all just where data are extant, where people have made observations. And as you can see, obviously, where people are and where they spend time, they come up incredibly brightly on the map. And some of those include transects across the ocean in various different places, and deep in the deserts of the Sahara, and far up into the tundra of Siberia. Humans do a very good job of characterizing and quantifying and counting birds on the planet. So much so that this database of eBird has every extant species, 10,500 species plus, every country is represented. And those data just keep coming in. So the idea that the human footprint, yeah, it can be a negative thing, but it also can be very much this positive of an opportunity to use a human as a sensor of, say, being able to see and hear birds and document those, and to gather information in these wonderful ways and then compile this. That gives you a lot of information and the ability to really identify where birds are, when on the planet, how many are there, and start to understand, well, part of this issue of population declines, right? The interesting thing about the eBird data, of course, and you all know this, is that it's heavily biased uh, for certain to where you go birding and when you go birding. And of course, most of the time that you go birding is during the day. So the eBird data set represents this wonderful, compendium of the distribution of birds and where we expect to find them. But it doesn't necessarily tell us about the period when all of these birds are actually on the move, when they're moving from one part of the planet to the other. Most migration happens at night, so eBird isn't quite the data set necessarily that you want to really understand what's happening in the most comprehensive sense of migration. Yes, you can do some really cool things with the eBird data for sure, understanding where birds are during the day and making projections about where they go at night. Thinking about a graphic like this, where we have birds that are wintering in South America, in the Amazon, and the Andes, and in Central America and the Caribbean, and this incredible pulse that happens every spring of these birds moving north across the hemisphere, some of them over water, crossing the Gulf of Mexico, some of them moving over land, and all moving into the US and Canada and occupying these habitats for breeding. The eBird data are wonderful at telling us what these species are and helping us understand, of course, where they are during the day and maybe connecting the dots with, okay, if that bird is occurring in Texas in early April in the spring, if a Bullock's oriole appears there and then appears somewhere farther north and west a little bit later in the year, we can make inferences on that. But it's not actively monitoring what's happening when these birds are on the move. And birds that are on the move at night, it's an enormous percentage of the species diversity in the country. I mean, it's like for the US, for example, you're talking about 80% of the birds at least are migrating at night. So the idea that you want to capture information about that, it requires something beyond the eBird data to think about. So we can think about other sources of information. And one of the ones with which I've been very fortunate to work with the BirdCast project is radar data. So radar, weather surveillance radar, there's one depicted in the bottom right of the screen. You may have heard it called NEXRAD or WSR, stands for Weather Surveillance Radar 88D. This is the current monitoring network for weather in the in the United States. And this sensor, this radar, is exceptionally good at surveilling the atmosphere, whether it comes to precipitation and all sorts of meteorological phenomena associated with precipitation, hydrometeors, if you will, from the meteorologist perspective. But it also does a great job of detecting other things in the atmosphere, in particular biological targets, if you will, birds, bats, insects. Because of the nature of the radar and the sensor, it's a 10 centimeter wavelength. That's really right in the sweet spot for detecting things like birds and insects along with precipitation. And to a radar, birds and insects and bats are just like big raindrops, if you will. So the idea that you could take advantage of a sensor network like this across the US to study what was happening in times when you couldn't see the birds, even if you couldn't identify them to species, because radar can't do that, but it can tell you how many birds are up there, and particularly powerful when you relate it to those eBird data. So if you could take the radar information and you could subtract out where the weather is, you'll notice these areas that are marked in white that highlight here. They're very blocky and irregular patterns of greens and yellows and reds. That's all precipitation. And we can identify what that looks like. We understand from our meteorologist friends and also from our own experiences ground truthing the radar, going outside and looking what's happening while the radar is surveilling. And if we could take that information and then remove it, well, suddenly we wouldn't be having really weather surveillance radar. We'd be having animal surveillance radar. And in this image, we've removed all of the meteorological information, and we're talking only about birds. This image is dominated by birds. Um, and so this is one of the critical concepts that at the beginning of BirdCast, we thought, oh, this would be a really powerful tool to quantify for the first time how many birds are migrating over the US on a particular night. That if with all the radar data, we could take out the meteorology and talk only about the birds, we'd have this really powerful opportunity to do monitoring, to quantify all sorts of features of migration, how many birds there are, what direction they're moving, what speed, where, and then a little bit farther, sort of more derived analysis of, well, what kinds of patterns relate to where these birds are? What's the habitat that they're flying over or from which they're emerging? What kinds of weather conditions are occurring? Building all sorts of models and testing hypotheses. So the raw material for all sorts of cool natural history information about the dynamics of bird migration, but also the science you could do. And so we've been super fortunate to be able to do some really cool stuff with this. So now, fast forward over those 25 years where we know what the radar data show, and we can train computers to recognize what's precipitation, what's bird migration, remove the precipitation, and then quantify all of that bird migration and do that in real time. So literally almost as soon as the radars are detecting bird migration, we can maybe 10 minutes or 15 minutes later gather that information and post it up into a graphic like this, where we're displaying, yeah, what looks like a traditional sort of weather map, but is the bird migration, the live migration map. So, and with most heat maps, you'll recognize the brighter and more intense the colors, the more birds are present. And so to the opposite with the cooler colors. And this kind of product where we can showcase how many birds are aloft. And also you'll notice arrows, the directions to which birds are moving. So generally in the spring, of course, all the arrows are pointing up. Those birds are moving mostly from south to north. This kind of a product was a long time in the making, and the power of being able to display something like this from the radar data and remove the meteorology, and then also make these quantifications. In this case, last night, we were talking about a little over 200 million birds aloft, most of them obviously in the center of the country where the weather conditions were favorable. Very powerful opportunity to be able to do that sort of thing. And this graphical approach really gives a nice sense of where across the country are birds on the move. We also are in this fortunate situation that we can handle those data in different ways. So rather than thinking about the graphical approach, we can think about, well, all right, what if we had a kind of a dashboard to view metrics, right? And to take the information embodied at that big scale and collapse it into a state or county level. Something that was a little bit finer resolution to understand, for example, Dodge County last night. Lots of birds on the move, talking about, over 1.2 million passing over the county that night. And we can quantify how many birds are in flight over the course of the night, the direction and speed of those movements, the altitude of those movements. We can relate that to sort of the seasonal progression and the expected progression. And we can also bring in those eBird data to give us a sense of, well, okay, we know what birds are on the ground and the frequencies of occurrence of those birds are changing. So we can understand what species are most likely on the move in these nocturnal movements. So this kind of approach where you can look at the large scale continental mass of migration as it unfolds over the course of a season, but also dig down deep into what's happening at a much more local level. This is one of the things that we think is very powerful about this idea of considering the scale of where birds are on the move, how they're moving, what the numbers are like, and how that relates to what's happening actually in places where observers are, where birds are stopping over in habitat, what's happening in the Great Lakes, what's happening in the Gulf states, what's happening in New England, and how is that changing over the course of the season, and how are peaks moving at different times. This is all information that we can gather from this kind of an approach, where we use this incredible, radar network that was obviously produced for some other purpose to monitor weather, but we can repurpose it to think about animal movements and birds in particular. Now, one of the other really cool things that we can do as soon as we can start to quantify and characterize and go back through like 30 plus years of radar data that have been collected and are archived online and in the cloud. As soon as you can analyze one of those, you can start to think about the power of computing, of cloud computing and machine learning to analyze a lot more of those kinds of images. So from each radar, each of the 143 radars in the contiguous US, over the past 35 years, they've scanned the atmosphere, I don't know, 750 million times. And so the idea of being able to analyze one of those and take out the meteorological data and talk about the birds and enumerate the number of birds, talk about the direction and speed that they move, etc., and then do that across this multi-hundred million data set archive, and then relate what you learn from that archive to other things in the environment. For example, weather data, temperature, wind speed, wind direction, pressure, and all of those characteristics from the ground up to 3,000 meters above the ground. Well, then you have the potential to make a model. And we did just that about 7 years ago. The BirdCast model was published for the first time. And with that, ushered in a whole new realm of possibility of really fun and exciting things to do. So this kind of a map looks a lot like the live migration map, but obviously this is a prediction. In this case, this is for tonight. So predicting a little bit less than moved last night, a little bit lower number, but a little bit wider distribution. Weather conditions are a little bit more favorable farther to the east across the country. But the idea of being able to relate the weather data, in particular temperature, which is the most important variable other than the time of the season in these kinds of models, to correlate to what the migration intensity is going to be. These kind of models behave really well. So we're talking about, when you think about trying to capture a large percentage of the variation that you experience in migration intensity on radar from weather data, these models capture about 85% a lot of the time, which is pretty good for an ecological model. Not perfect, but it's far good enough to be able to say, okay, there are going to be a lot of birds on the move on this particular night in the central Texas and in parts of upstate South Carolina. That kind of information is now possible. We can do it for 3 days into the future and not lose a whole lot of accuracy in the model. We can even do it more than 2 weeks out. And obviously, yeah, the model is only as good as the weather data that go into it in terms of the prediction. But the model behaves really well and has done a great job at predicting when birds are going to be flying over a particular area. Really exciting evolution that as I mentioned, it's only been about 7 years since we were able to do this. So very exciting breakthrough that, again, was the result of this kind of connection between the computer scientists allowing us to work with all these massive amounts of information and messy data and to be able to package it in a way that made sense. And then obviously the expertise on the bird side as well that allows us to understand, well, what's birds and what's rain, or what species are on the move and how might that relate to the patterns we're seeing. So with that in mind, I want to come back to this idea of, okay, we now have a couple of different ideas out there that I've talked to you about how to monitor birds on the move and where they are on the planet. Some of that is human, and some of that is technological, remote sensing. And at the beginning, I mentioned these population issues, the concern that we have, the conservation challenges that we face when it comes to bird populations. And again, I want to reorient to, the global human footprint and where we are and the challenges we bring with us, that we might employ this kind of monitoring strategy, this kind of way of sensing where birds are when and how they're moving to try to answer some of those questions and address some of the problems that birds face and some of the hazards so we can reverse that curve. So obviously, one of the things that goes along with where humans are is built infrastructure, right? So the expectation of what's going to happen in the built environment over the coming years is expansive. I mean, the construction, the appearance of new structures, the repair of old structures, and the maintenance of old structures. There's a lot of space on the planet that's going to be built for certain. And along with those buildings come particular hazards to birds, reflective and transparent surfaces, glass, right? Structures that birds cannot perceive as solid and will try to fly through or fly into, creates serious problems. So too, also with this infrastructure comes various uses of energy. And in this case, an example of where light pollution is distributed around the globe. And this light pollution is extreme, and it has dramatic impacts for all kinds of organisms that are active at night, humans included. But in particular, when we think about birds, light is a very powerful stimulus that attracts birds to it and also disorients them. So this combination of the built environment and the kinds of structures that we're erecting that have this transparent and reflective material that birds can't perceive and that creates real issues for them in terms of navigating and orienting around it, plus the combination of nocturnal pollution, of light pollution when birds are moving that attracts and disorients them into these areas where the infrastructure is. This is a serious issue. And we have this notion that light pollution and glass, these are deadly when it comes to birds. I am sure many of you have had the experience, perhaps unfortunately, of seeing a dead bird beneath your kitchen window, or perhaps you do monitoring in urban areas around buildings. The combination of light pollution and glass is really dangerous for birds, and we know what to do to address that for sure. We know that when we remove light, for example, pictured here, two different studies, as soon as we remove light, positive things happen for birds. So on the one hand, a study that we published a couple of years ago about the McCormick Place Convention Center in Chicago, which some of you probably know about. It's a notorious bird killing building that has actually been actually changed for the better in the last year for various reasons. I'll get to that in a second. But the idea that in that building, we can see that when even indoor lights are left on and windows are not shaded, those are deadly areas for birds in terms of attraction. And if we reduce that surface area of light from those indoor lights, we decrease the number of birds that collide dramatically, like over 50% if we cut the windows in half. If we were to leave all the lights on, it would be even worse in terms of, an enormous increase in the numbers of birds killed. We also learned this from the outdoor light perspective in Manhattan, here where I am. I've had the good fortune to work with the Tribute in Light organizers and producers, the National 9/11 Memorial and Museum tribute to those lives lost in the terrorist attacks in 2001 in September. We've had the opportunity to do some amazing work down there where we can turn the lights on and off and see how birds respond. The details of the right-hand graphic are not so critical beyond understanding that in those green areas, the bright lights are on, the gray areas, the lights are off, and you see this incredible periodicity of three different features of bird migration there that all correspond to the lights off. In the top, it's the numbers of birds when the lights are on. The aggregations are intense. The numbers of birds skyrocket, attraction, disorientation. In the middle there, speeds of birds traveling. When the lights are on, they're circling, they're slowing down. As soon as the lights are off, the speeds increase dramatically. Birds fly on their way. They stop circling. They move away from the tribute area. And then also flight calling. Birds vocalizing at night increases dramatically when the lights are on during periods of confusion. As soon as the lights go off, much more normal behaviors, flight calling decreases to actually zero in many instances. So this kind of relationship of birds to light, we can understand very well. And there's a simple solution here of removing as much light as we can. Similar when it comes to glass, we know what to do. And we can treat that glass. I mentioned the McCormick Place Convention Center, and in 2023 in October, a massive bird kill happened there. 1,000 birds almost on a single night. Part of a really serious and sad event that occurred in Chicago and other areas nearby and environs on that night. And the places where birds were colliding were again this reflective and transparent glass, often where there was light. And that simple solution of making the glass visible to birds, putting designs in the windows that are 1 inch by 1 inch or 1 inch by 2 inches or anything like you see in this right-hand image where the glass is suddenly, yes, it's still reflective and transparent, but suddenly it's apparent because there are these non-reflective and opaque items there. Birds perceive that and they don't collide. And what you see in the right here is actually the result of some pretty rapid and serious work to treat the McCormick Place Convention Center, this notorious bird killer for the last 50 years. And as soon as the windows were treated, we don't have the full numbers yet, but it looks like the collisions declined by 90 or 95%. I mean, like amazing, amazing change. So this idea that we can act on how to address this problem. We can start to inform how and where we do conservation action to address something important like this, where over 1 billion birds are killed every year in collisions with windows. That's like 30 birds a second. It's an enormous number, and we can address that by controlling light and treating the windows. And we can also think about how do we inform that kind of conservation action with more science, right? So again, the monitoring that we can do, the study of the natural history and the science, we can move that into the conservation realm and think, okay, well, we understand that every year, in the spring and the fall, in the spring, 2.5 to 3.5 billion birds are moving north through the U.S. Another 4 to 5 billion, are returning after the year's productivity. Understanding where these birds are at particular times and what the patterns of occurrence look like over the course of time. Where are the densest areas regularly occurring? What times are they regularly occurring? When does peak migration occur? What kinds of statistics can we generate that tell us, okay, when does 50% of the migration traffic pass through, Wisconsin or New York or Texas? And we can use that kind of information and the kinds of modeling that we can do to make some really important evolutions of the science into tools for conservation. So this is that same approach of thinking about a forecast model and taking the forecast data and simply relating it to areas where birds are forecast to occur in large numbers and where that overlaps with light pollution. And this graphic comes from Colorado State University. They've been working quite taking the lead on some of the lights out analyses that we've been doing. And this idea of creating a tool that would allow you to see broadly, okay, I understand where migration is going to be occurring, and I can forecast that based on scientific approaches that we can detail and characterize and have been peer reviewed. We can relate that to where light pollution is occurring and where the built environment is, and we can issue these lights out alerts in particular places to highlight, oh, okay, when might it be a good time, if you're not doing it already, to get active and to make a change. We can also look at this at a much finer scale, and we can think about it from, the state level in Wisconsin, and we can go even farther to look down at the city level and think about, because we have resolution of these data to get much, much finer from the scale of the continent down to, a county or city level. It gives us the power to be aware of what's happening in a way that we have not been able to see before and experience before. And of course, with that power, then we can act on some of those concerns of, oh, I have to make sure to tell all my friends to turn lights out tonight. And I really have to get on treating my windows if I haven't done that. This kind of information suddenly becomes possible, not just from the perspective of learning about bird migration and the natural history and engaging with it as a birder, but stewarding it as a citizen that's concerned. And I'm very happy to say that the data that we've collected in BirdCast can go to some really wonderful ends. So yeah, we can promote the conservation actions for sure. We can also legislate this. So the science behind BirdCast and that we're producing has gone into some laws, in particular in New York City, where we're now uh, reducing outdoor lighting in non-essential buildings that are owned by the city, turning those things off during, or trying at least starting to, turning them off during peak periods of migration over the course of the night. Thinking about bird-friendly materials. There are a couple laws on the books in New York that cover this and that now legislate it for us going forward and thinking about green cities and being sustainable. This is one of the components of one of the things that we for sure want to do. So let me go quickly into sort of the last bit of this talk. Yeah, BirdCast has focused on radar data, and we've talked a lot about it. It also employs eBird data and in observational data. There are lots of other cool ways that we can study migration that are also elements that we've explored and are exploring in BirdCast. One of them, of my a former high school student I used to mentor, who then came to Cornell to work on BirdCast, and then eventually came back after he got his PhD to work on BirdCast again. Now is a professor at University of Illinois in Urbana-Champaign. Benjamin Van Doren has created this wonderful system of monitoring migration by sound. One of the things I've been interested in for my whole career is flight calls and the sounds that birds produce when they're migrating. Finally, now, again with machine learning and this whole idea of big data, in this case, big audio data, that we can train models to identify these things automatically and put this kind of a different sort of a dashboard up where we look at, for example, from the fall last year, species breakdowns of what birds are flight calling over Chicago and what are the magnitudes of calling that we're seeing. Really fascinating, very different approach to studying migration. The flight calls tell you the species involved, very different from the radar that's telling you the numbers, and a nice complement to sort of understand migration from a more comprehensive perspective. There's also sort of the fun of looking backwards in time. So radar has been around for a lot longer than just the last 30 years. Radar technology is just over 100 years old. We first saw it employed sort of in the grand scheme of things for military uses, but very quickly thereafter, post-World War II, the first weather surveillance radars arrived, and we still have some of those data, albeit on film, 35 millimeter and 16 millimeter film, but they capture bird migration as well. And you see various different versions of radar data from these films that we have. We can now start to go back and digitize these films, and then again use things like computer vision and sort of some advanced computational methods to extract the information and to look backwards in time to think about, well, okay, what can we say about how has the peak of bird migration in Louisiana or Texas changed over the last 70 years rather than just looking at 30? So the potential is enormous to start going backwards with some of interestingly, the newest technologies intersecting with some of the older technologies where we have these archived data that are still in some analog format that need to be updated to understand them. And of course, we can also do fun stuff. Not that this other stuff isn't fun, but from the birding perspective, the idea of thinking like, well, I don't have a lot of time to go birding. Maybe, for example, I want to be very specific and sort of maximize my chances of seeing something really unusual. And so there are opportunities now with the eBird data and with all of this meteorological and climatological information we have to start thinking about maps like this and the patterns of when we see certain kinds of meteorological conditions. In the center here with this arrow pointing north, that's this massive flow of southerly wind that's coming straight out of Central America. And associated with those kinds of patterns are the arrival of things in, the eastern Great Lakes of burrowing owl, groove-billed ani, fork-tailed flycatcher, birds that are not normally part of your everyday birding, but vagrants that do occur in predictable ways. We can start to think about these relationships and not just sort of luck into rare birds, but actually start to understand, well, okay, if I'm smart with the way I go birding, I actually can go out and plan to find them and go to the places and actually discover them. And this has happened many, many times. Really fun sort of related pattern and related opportunity to what we can do with the BirdCast data. And again, yeah, the interest is strong, the passion is there, but I do want to remind us that part of the reason that we do all of this work is really to think about bird conservation and having more opportunities to have our children and our grandchildren and our great-grandchildren experience these kind of amazing migrations and this in incredible numbers of birds. And again, reverse this curve that we've seen in the past 50, 100, 500 years and keep birds around and just be a better steward for these populations. Now, with that in mind, again, this has been BirdCast, an effort that is multiple different people, multiple universities, lots of different skills beyond even just the computer science and the ornithology. And all of my team members are deeply involved in this project, and it's certainly a passion project. And for your attention, I just want to I'm very grateful, and I thank you for your audience. The reason we do this, yeah, we're very excited about it, but we're super excited that so many people really enjoy it and that visit it and they're using it to think about how to answer questions about bird migration, how to inform the way they go birding so their experiences are more intense and better. And also, like I said, how to protect these incredible organisms so that we have them around for a long time. So I want to thank you. Thank you very much for your audience.
Okay. I don't even know what to say. This just absolutely fascinating
Uh-oh. Oh, good. It's a
and
positive thing. You never
amazing
know.
things. Where a firsthand account of where these rarities were coming from. 2 years ago, when we had that hurricane, sucked up a bunch of American flamingos.
Yep.
Eyewitness, we saw American flamingos on Lake Michigan, right on the beach. So it's like, firsthand accounts of it, right there in action. So it's amazing what these weather fronts and the power and their that they have, and the birds get caught up in that, where they end up, and um it goes, to me, it goes right back to, if I'm seeing a Blackburnian warbler in my yard, it's like, I wish I could talk to it. We could, the stories that bird could tell, and where it's been and where it's going to go and things like that. So I'm sure we've got some questions here. Um, for those folks online, you can type them out.
I'm going to put my email in the there. Sometimes there are more, either people are a little embarrassed to ask questions or there are more questions than we have time for. So I'm going to put my email in there. So you have it, just in case, so everybody can ask questions whenever they feel comfortable. We certainly cover whatever you'd like now. Absolutely.
Awesome. Questions from the crowd here? Anything? Okay, so the question was, can you recommend a specific product for window covering, or to reduce uh,
Yeah,
collisions?
collisions. Yeah, there are some great ones now. And I have no benefit in mentioning this other than I know the person that does it. Feather Friendly is a great outfit, and they have some really nice do-it-yourself kinds of decals that you can apply. They also work closely with various unions around the country to work on buildings. They're the ones that did McCormick Place. But there are others as well, Acopian Bird Savers. There are even the ability to make these kinds of of designs on your own, so you don't necessarily have to buy them. There are specifications. American Bird Conservancy has a wonderful set of resources on their website, and I can share some of this with you guys later, just so that, to detail where you can go and look for it. But there are lots of different ways. But feather friendly is one that comes around a lot, just because it's been pretty high profile recently. That can work on your kitchen window, or if you happen to own a building and the windows are not treated, you can talk to them and they can help you.
Awesome. If you could kind of send an email or something like that, we can do a follow-up and then post it in our newsletter, things that um, could get the word out as well. That would be awesome. Um, any other questions? I saw some hands here before. Brad. Um, so the question was, is there any federal funding involved in BirdCast?
Good question. There was, and right now there is not. That's not because we're necessarily wanting for funds, but just we don't have them at the moment. We're funded. We kind of leveraged the National Science Foundation project that ended, that really kickstarted BirdCast in 2016, and since then it's been various different kinds of, at times federal funding and state funding, but a lot of private foundations as well, sometimes donors funding it. So the work is going to continue. The one challenge, though, when it comes to federal connection to the project, obviously the fact that the data are federally collected, publicly available through NOAA and National Weather Service. There was a scare last week when it looked like some of the contracts were going to be canceled when it came to NOAA in particular and Amazon, which is the thing that Amazon Web Services hosts all of these radar data and the computational power to do what we do very quickly. So it's a very close relationship there. So it's the funding, like, we're okay. The access to the data, that could be tenuous, and we have downloaded a lot of it. We have access to it, in other ways, but the ease of access is one of the things that allows BirdCast to continue the way it does. So that is a concern for us for sure. But in terms of the people that are working on the project, they're funded by various other sources. So the expertise per se is where it is. It's not going anywhere, which is great. I see that there's a question in the chat about practical applications besides light pollution, for how we could think about the migration monitoring data. Without question, there are some really cool practical applications. That include, yes, informing any kind of energy operations into when to turn off, when to shut down, when to alter behaviors of having lights on, or having wind turbines operating, or gas flaring, or anything like that. There also are applications when it comes to aviation, right, and altering flight paths. In particular, yes, commercial aviation for sure, but in particular, emergency and sort of private aviation. That's a much bigger concern because of the altitude at which, say, emergency medical evac helicopters are flying. Those things encounter birds all the time. So the idea of being able to provide forecasts to them that have both the bird migration information and the species that are involved, to understand, like, oh, okay, this is a really severe time because there are a lot of waterfowl moving. We can do that, and that sort of application to aviation makes a lot of sense. There's, of course, a lot of discussion about avian influenza and relating bird migration patterns to where transmission events may occur. So kind of the epidemiology of diseases, that's also another place. So the applications are pretty far and wide, pretty interesting and diverse.
I'm going to ask a quick question. Does the frequency of the light have to do with frequency of the bird collisions? Is there a way we can change the frequency of the light, or?
Yeah, good question. So yes, there have been a number of studies over the last 30 to 40 years that have highlighted different wavelengths, in particular the blues and whites, as being very bad. But most of the study, in terms of very attractive and disorienting, for a whole lot of reasons that I can explain by, if it's a long story, but the short of it is there's attraction and disorientation, in particular by these blue and white wavelengths. However, the studies have not looked so well at the intensity of the light, and it seems like there was a relationship between the color and the intensity. There are some studies ongoing now that are looking at that. But by and large, for birds, the blue and the white light, or the bluer and the whiter light, tend to be a lot more problematic. So if you can reduce those, and you can shield those so the light just doesn't go everywhere, or turn it off, obviously, where you don't need it, that makes a huge impact. And for birds, even just directing the light down so that it's not creeping and escaping everywhere, whether it's with shades on your windows for buildings at night, or, shielding on the lights themselves, that stuff works, and it works really well. But as far as the way the intensity of the light relates to that and color, that's starting to come out now. In probably the next 6 months, you're going to see a paper or two on that I think are going to answer a lot more questions about, well, okay, what if I have, really dim white and blue light? Is that better than, bright yellow light? Well, yes, it turns out, so there's an interaction there that we're still starting to understand, but wavelength definitely plays a big role for sure.
Interesting. Another question from the chat here. Can BirdCast see climate changes or areas of drought or deforestation?
Yeah, good question. So we can definitely see climate change in the perspective of shifts in peak migration and where that's happening. If you look over 30 years, you see this really interesting pattern. We published on it a couple years ago, where the arrival of peak migration is getting earlier and earlier, say each spring, as temperatures on average increase. But that doesn't happen evenly across latitudes. So birds are trying to respond, to changes in their environment by altering the speed with which they're moving. But at some fundamental level, that peak of when the largest numbers and diversity of birds are moving is getting generally earlier and earlier when you look over time. And of course, the problem with that is, well, it leads to these kind of mismatches of the birds arriving and there being like past prime on the food, or some extreme situation has happened and there's no food. So yes, we do definitely see the footprint of climate change. We also see patterns where, certainly related to drought and the presence of birds in areas where there's a lot of water or not, and how that changes over time. Also, fire and wildfires. And so these environmental impacts and changes in habitat, even over time, and looking at how many birds emerge out of a particular habitat on radar, you can quantify that and look at changes over time. So yes, we can see a lot more than just say what's happening in near real time. We can look over these longer periods of time, because the data set is so big at this point, to start to ask other questions and see other patterns. It's a good question.
Any other questions here from the studio audience?
I might take the next ones by email, because I hear a bedtime coming for my daughter.
Okay. All right.
I'm going to keep them awake, and I'll blame you
Okay.
guys.
Yeah. It was just a note that it's fascinating that you're looking now today, but being able to go back and look in the archives of some of that,
Yeah,
to me, that's where we're really going to be doing the learning, like
for sure.
the changes that are happening, learning what was, rather
Yep.
than, a
Looking
few
forwards.
observations.
That's
Yeah.
right.
So,
Looking forwards and backwards is the key, for sure. I agree.
um, you know, telling my grandkids, whippersnappers, there used to be a lot more birds, it just doesn't hit home. But if you've got, the data to back it up, and the radar images from the bygone days. So that's
Yeah.
amazing. So I want to really thank you. I know it would be popular, and I gotta thank our program chairman here, or Deb Pritchard here, who goes and contacts our speakers and everything, and she said, "What, I find that fascinating. What if I contacted him?" I says, "Go for it. I think this is going to be a big hit." So
Anytime. I really appreciate your audience and the fact that you have the interest. Happy to do it again because there's plenty to cover. I mean, we just scratched the surface, of course. So happy to come back and talk.
Oh, thanks much. So big round for Farnsworth. So with that, we'll let you tell some bedtime stories and
The next
uh,
migration.
good birds to you there.
And to you, they're coming. I promise they're coming. Not too much longer. The big waves are approaching. So enjoy.
We've got a bird festival Mother's Day weekend, so I'm counting on you. Okay.
Be in good shape.
All right.
Good night,
Thanks
everybody,
much.
and thank you.